Hi everyone. Today I'll be explaining IoT Pi, a machine learning based lightweight framework for cost effective distributed computing using IoT. This work has been done by Shao, Deepraj Chowdhury, Supal Singh Gill, and Rajkumar Bua. This work has been published in the journal Internet Technology Letters by Will. University collaborated are IIIT Naya Raipur, Queen Mary University of London, Melbourne, University of Melbourne, Clouds Lab. These are the further I will be discussing introduction, proposed methodology, result and discussion, conclusion, data availability. Introduction. It is even verified that the devices is capable of monitoring cloud resources. The appearance of Raspberry Pi is the integration of both powerful ARM chipset and embedded device. Massive computing nodes are working in parallel to provide powerful computational capacity in comparison to the traditional limited clustered or single node. It is also elastic to manage the life cycle of all resources on the cloud. Many cloud services vendor provides dedicated software development kit to manage cloud resources, which implement same purpose as of a software defined network as well. However, cloud technologies have been dominated by a small group of companies with large volume of computing resource. It is not affordable to run tasks based on intelligent AI intelligence when the business scenario is beyond the scale of the capacity owned by the cloud service company. However, the resources on the cloud are viable to be managed in real time. The main contribution of IoT Pi are verify the concept that IoT node undertakes modern machine learning tasks, identify the ideal tasks of cloud resource to manage the lifecycle adaptability, explore organizing cloud resources by machine learning techniques from IoT edge devices, minimize cost of resources usage when using cloud. System architecture. System architecture is of three parts: client side, server side, and elastic resource. This is the architectural diagram of IoT Pi. Client side. Client side contains the main crucial component in the entire system that a client nodes control the entire resource planning and life cycle, which consists of defining of purposes, defining the hardware, defining the storage, defining the network and security, defining the management process, testing and analysis of the process, including the HTTP connection library and the machine learning framework. The HTTP connection library is mainly used to undertake data retrieval tasks that it connects to remote server to fetch the system information of the instance on the cloud. The retrieved data is near real time and can be stored in a local cache for further analysis and model training. The machine learning framework is sufficient to be lightweighted so that it can be running on critical environments such as Raspberry Pi nodes with few dependency. Also, it has been integrated with Scalar. Server side. Server side consists of web microservice framework, a cache backend, a cloud service SDK that access the cloud resources with management privilege and a SSH connection library. The web microservice framework provides the application running as a normal web application and easy to be managed in the circumstances of microservice orchestration. Elastic resource. Elastic resource can be implemented on a cloud service such as AWS and GCP or self-managed by bare metal clusters such as OpenStack cluster. It is optional to set cache service as a cache backend in the server side. Additionally, it is required for cloud service provider that manage the instance on the cloud must be capable of scaling in or out with the cloud service SDK or API. This is the key step of adapting resources by the system. Result. The execution time. In this, TSR means the training sample rounds and PSR means the prediction sample rounds. It has seen the TSR value is 40 and PSR value is 10. The elapsed time is 256.42 seconds. Similarly, the TSR is as 80 and PSR as 20. Then the elapsed time is 328.64 seconds. Finally, with the TSR value of 400 and PSR value of 100, the elapsed time is 871.368381 seconds. Accuracy. Mean training accuracy of KNN and SVC algorithms which are used is 66.75% and 74.75% respectively, while the testing accuracy is 78% for both the algorithm for a ideal instance. Where for a busy instance, the training accuracy of KNN and SVC is 92.50% and 93.75% respectively, whereas the testing accuracy for both the algorithm is 94.99%. This is the TPR versus FPR graph for the algorithm which we have used. There are four algorithms: SVC, logistic regression, KNN classifier, and MLP classifier. Conclusion. IoT Pi has been proposed to make IoT device as a main working platform in real world to optimize the cost of cluster uses. IoT Pi framework consists of three phases: client side, server side, and elastic resource. Further, four different machine learning algorithm models SVM classifier, logistic regression, KNN classifier, and MLP classifier are implemented, and results show that these models are able to predict the ideal state instant with a accuracy of over 70%. High availability is one of the most critical topic in massive high performance computation and cloud computing. The software and the codes of the IoT Pi is available in the GitHub account of Dr. SS Gill. The link can be seen. It's github.com/imssgill/IoT Pi. Thank you.